example of changing the order of integration. This example is slightly different as in our previous two examples. So let us start with the question. This integration is from -2 to 3 and y square minus 6 to y dy dx. Now as all you know that the inner limits are functions of y. It means in this example your integration is with respect to x first and then followed by y. So to change the order, it means now we instead of x, now we want it with respect to y first. Okay. So let us start to consider about the region of integration. Now to draw the region of integration, we should see the limits, and from the limits we have to find out the corresponding curves. So let us start. Now x equal to y square minus 6. This is the lower limit for x. So x equal to y square minus 6 means y square equal to x plus 6. All you know that this is the equation of parabola, but this is not the standard parabola. So how you will get to know how to draw this parabola? So to draw this parabola, since y is the square, it means it is a symmetric curve, symmetric about x-axis. Now to get the vertex point where it intersects to the x-axis, what we have to do is put y equal to 0 in this equation. So if I substitute y equal to 0 in this equation, I will get x equal to minus 6. It means this parabola is with the vertex at minus 6 comma 0. So you can draw this parabola with the vertex at minus 6 comma 0. Okay. Now see the upper limit for x, that is x equal to y. We know that this is the equation of a straight line passing through origin. So this line you can draw, that is x equal to y, which passes through the origin. So this is about the limits for x. Now let us switch to the limits for y. Now if you will see, the lower limit for y is minus 2, which is the equation of a straight line parallel to x-axis. Upper limit for y is y equal to 3, which is the equation of again a straight line parallel to x-axis. So this y equal to 3 is one straight line, and y equal to minus 2, this is the straight line parallel to x-axis. Okay. So after drawing these curves, now we have to discuss the region of integration. But to find out the region of integration, we should get the intersection points where these curves are intersecting. So if you will see here the parabola and this straight line is intersecting. So we have to know the intersection point, that the coordinates of point A and C. Now to get these intersection points, we have to solve these two equations simultaneously. That is y equal to x and y square equal to x plus 6. So after solving these two equations simultaneously, you can see here we are getting the two values of x, that is x equal to 3 and x equal to minus 2. So if I substitute x equal to 3 or x equal to minus 2 in this equation, again I will get y equal to 3 and y equal to minus 2. It means we can say that intersection points are 3, 3 and minus 2, minus 2. So let us write down those intersection points. So the coordinates of point C is 3, 3 and the coordinates of point A are minus 2, minus 2. Okay. So now we can conclude that OADBC is our region of integration. So let us shade this region of integration. Okay. So how we will get to know this region of integration, as we have discussed in our previous videos, that about if this is the limit for x varies from left to right. So if you will see, the lower limit for x is the parabola. So the parabola starts from here. It means you have to start to see from this point to the right side, but up to where x is varying. So if you will see, the upper limit for x is equal to y. It means up to where? Up to this line. Okay. So for x, you can have the region from this boundary of this parabola up to this line. So this region which I have shaded, that will be for x. Now let us find out for y. If you will see, the lower limit for y is minus 2 and the upper limit is 3. It means the region for y bounded between these two straight lines. So you can see this is the line y equal to 3 and this is the line y equal to minus 2. So for y, you can have the region bounded between these two lines. Okay. So x is in between this parabola and straight line, and y is in between these two straight lines. So you can conclude which is the common area, that this shaded part is the common area. Always you find out the common region from x and y, and that common region is the required region of integration. So let us shade, I have shared this region. So OADBC is the region of integration, right? After getting the region of integration, to change the order, what we have to do? We have to consider the strip parallel to. Now, which axis you have to consider the strip parallel? How you will find out it? As I told you, the given order, if you will see, this is the function of y, it means these are the limits for x. Now we want to change it, it means we want now with respect to y. So if you want your integration with respect to y first, it means you have to consider your strip parallel to y-axis. So let us draw strip parallel to y-axis. Okay. So I am drawing this strip over here which is parallel to y-axis. Now one thing you have to see over here, always whenever you will draw a strip given in a given region, you just find out, you move that strip along the region and you just see that the end points of the strip are intersecting the same curves or not. That is very important. So if you will see over here, this strip, when it is at this position, the end points are along parabola. You can see it in the diagram clearly. The end points of the strip are along the parabola. Now as the strip will start to move and when it will come over here, suppose the new position of the strip I am drawing here. So when the strip comes at this position over here, now you can see the end points of the strip are changing. Now if you will see, the lower end of the strip is along the straight line and the upper end of the strip is on the parabola. It means what? Whenever such case arises that the end points of the strips are changing, it means your region of integration gets divided into more than one parts. Now into how many parts it is getting divided? So that you can easily identify by moving the strip and you just check that the end points of the strips are remaining same. Okay, so here you can easily get to know. I am drawing this dotted line over here. So this dotted line is the line of separation of the region of integration. So you can see when the strip is before this AB, towards the left side of AB, the endpoints are different, and when the strip moves after the AB towards the right side, the endpoints are getting different. So it means what? In this diagram, the region of integration gets divided into two parts, right? So this ADB is one part and ABC is the second part, right? So in both the regions, we have to find out the limits separately. So let us start. So in the region ADB, now if you will see here ADB, the end points of the strip, now to find out the, in the region of ADB, to find out the limits for y, look at the end points of the strip. For y you have to go in an upward direction. So the lower end of the strip and upper end of the strip, both the ends, if you will say, it touches on the curve parabola. So from the equation of the parabola y square equal to x plus 6, you can see the values of y will be plus or minus square root of x plus 6. Now which is the lower limit and upper limit? So to decide that, you look at here, the lower end is in the fourth quadrant where y is negative. So the lower end of the lower limit for the y will be minus of root of x plus 6. And the upper end is in the second quadrant where y is positive. So the upper limit for y will be root of x plus 6. To find out the limits for x, you start from the point D up to this dotted line AB. So at point D, the value of x is minus 6 and along this dotted line AB, the value of x is minus 2. It means x varies from minus 6 to minus 2. So this is about the first region. Now come to the second region, that is ABC. In this region ABC, look at the end points of the strip. The lower end of the strip is along this straight line y equal to x. It means this is the lower limit for y. So y varies from x to. About the upper limit, if you will see here, upper end of the strip is on the curve parabola. So from the equation of the parabola, you can get the value of y as a root of x plus 6. Since this upper end is in the second and the first quadrant, so we will consider the positive value of the square root. So y varies from x to root of x plus 6. And to find out the limit points for x, if you will start from this dotted line AB, this second region start from this dotted line AB up to the point C. So on this dotted line AB, we know that x is minus 2, and when this strip, it will start to move from AB to the point C. Here the value of x is 3. So x varies from minus 2 to 3. Now to write down the integration by changing the order, since this region gets divided into two parts, so this given integral gets splitted into two parts, and here we have to do the addition of both the integrals. Okay, so this is the region, this is the integral in the first region ADB, and this integral is in the second region ABC. So here we will note down now y goes from minus of root x plus 6 to plus of root x plus 6, and x goes from minus 6 to minus 2, and plus you can see here in the second integral y goes from, we know that here, x to root of x plus 6, and x varies from minus 2 to 3. So in this way, whenever you will have the splitting of the region, you can have the splitting of the integrations too. So now I'll be aside, all you just take the screenshot of this, and that will help you to note down the example. Okay, thank you.